Hello, welcome to another video for this class. In this video, we are going to study section 5.4 of the textbook and complete our study about trigonometric functions. So far, we learned about sine and cosine function. We defined sine and cosine of the function by using the right triangle in a circle. But pay attention that a triangle has three sides. So there are, because we are taking ratios when we define sine and cosine, there are other possible ratios that to take to define sine and to define new functions. So I'm gonna draw. So recall that if you have, let's say this is the coordinate system xy plane, and suppose you have a circle, and this circle has radius r, and yes, the radius is r, so this is gonna be r, this is gonna be r, right? And pick a point, okay, any point. So for example, this point. So this point that sits on the circle, in terms of coordinate system, this point has a coordinate value of x and y, right? So if you look at this point on the plane, you can identify this point as having two values, x value and y value. But this point also uniquely determine the other thing is that it's because it's on the circle, it corresponds to a unique angle. So if you connect the point to the origin, that creates an angle, let's call it theta, that creates an angle with the horizontal axis, right? That angle is unique, which means that if you fix a point on the circle, then the angle that it makes toward horizontal axis is unique to this point. So when you in general, when you have this point on the circle, you can either represent it by xy value, or you can represent it by this unique angle. And then from here, we went further and we said, okay, now let's draw this right triangle. Okay, so we said, look, if you create this right triangle, so this is the right triangle, then we know what are the values of the sides of this triangle. Okay, because we know that this side has the value of x, because the horizontal value coordinate of this point is x. This side has the value of y, the height is y, and this side is r. What is r? R is the radius of the circle. Okay, so then we end up by a right triangle that we know the value of its side. And then we defined, so far we defined sine and cosine. Do you remember sine? What is sine function? So we said, look, take a ratio of y over r, right? I think maybe in the previous module, I am imagining that you have a unit circle, which means that r is 1, but it doesn't matter, because if it's 1, then you don't have to write it. But I'm going to here define it in a more general case. In more general case, this circle can have any radius. Radius can be 1, can be 5, can be 10, or anything. So we use r to denote the radius. Now, if you take the ratio of y over 1, that's going to be, then we define this to be sine function. And it's based on theta, the angle. So sine function, so it's very simple. Look, you recall geometry. You have a triangle. You have a right triangle. You have the value of the size of this right triangle. So you can compute this ratio, y divided by r. Now name it. So whenever you do this for any angle, when you take this ratio, we name it as sine function. We say this is sine of angle theta. You can also similarly take the ratio of x over r, and we define this as cosine of theta. So we said whenever you are in this situation and when you compute the ratio of x over r, this is cosine of theta. So far it's not new. We learned about this in previous module. Now, because technically we can define sine and cosine by ratio of right triangle, how about other ratios? For example, look, you may say, hey, I can also, if it's about taking ratio, we can also look at the ratio of like y over x. Let's divide y over x. We say, okay, that's also interesting. That's possible and it's interesting possible. Let's name it. And then we name it tangent function. So when you take so tangent function, the input value is theta, it takes angle. So it takes angle like 30 degrees, 60 degrees, 90 degrees. So input is angle. The output, what is the output? Is this ratio, y over x. Another possible, the textbook defined as secant. Okay, so it's r over x. So you may say, listen, it is also possible to take this ratio r over x. We say, okay, let's name this as well, something. And then we name it secant function. So secant function, take the angle, and then it returns you this ratio. Another possible ratio is to take r over y. How about this? You can divide r by y. It's going to be a number. We define it as cosecant function. So these are just names. We give them name. And finally, the last possible ratio is to divide x by y. And then we define it, we name it as cotangent function. Okay? So look, now we are done because now we have all the 6 possible trig function. Again, look, you have a right triangle and it has 3 sides. So technically it's possible to calculate a 6 combination of ratios. We can divide x by y, y by x, y by r, and so on. And then we give them name, like when you do y by r, that's going to be sine. So this is one function. You divide x by r, that's going to give you the cosine function. If you do y divided by x, that's going to be tangent. And if you flip it, which means that divide x by y, that's going to be cotangent. And if you divide the radius r by x, we name it secant. R divided by y, we name it cosecant. And these are all basic trig functions. So in general, we have 6 trigonometric functions: sine, cosine, tangent, cotangent, secant, and cosecant. But then, look, there is also relationship between these functions. You can either look at them in terms of like this ratio of the right sides of the right triangle, and also you can look at the relationship between these functions. For example, what is the relationship between tangent and sine and cosine? Okay, so what is, I'm gonna show you here. So look, for example, what is sine? Sine is, so I want to show you that if you divide sine by cosine, take this ratio, sine by cosine. So what is sine? Sine is y divided by r. Cosine is x divided by r. So if you do that, then it's gonna be y divided by x. Okay, but we said y divided by x is tangent. So this is actually tangent of theta. So from here, you can see the relationship between tangent function and sine and cosine function. Tangent function is the ratio of sine and cosine. So, and you have it right here. Tangent function is the ratio of sine and cosine. So in this way, we can derive identities. What are identities? So we have these 6 functions, but they are connected. There is a relationship between these functions. And I show you the first identity, that tangent is in fact sine divided by cosine. Let me show you one more time. So look, what is tangent? Oh, sorry. It's right here. Tangent is y over x. But if you divide sine over cosine, you also end up by y over x. So in this way, these two are equal. Now, let me show you the next identity. The next identity says that there is a relationship between secant and cosecant. And this is the relationship. So let's see. What is, so the identity says that secant of theta is 1 over cosine of theta. Let's see if this is true. So what is secant? Secant is r over x, right? And what is this equal to, what is cosine? Cosine is x over r. Yes, that's right, because if you flip this, it's gonna be r over x. So yes, this is correct. You see that? So secant is 1 over cosine. And cosecant is 1 over sine. So this is the relationship between cosecant function and sine function. The relationship is that cosecant is also 1 over sine. And let's see that. So what is cosecant? So cosecant is, let's see that. It's r over y. What is sine? Sine is y divided by r. Yes, if you flip this, it's going to be r over y. So that's it. And the last one is the relationship between cotangent and tangent, and that's, I can show you here. Look, it's even right here. Look, what is tangent? Tangent is y over x. What is cotangent? Cotangent is x over y. So you see, it's just, you can get one of them by flipping the other. Do you see that? Do you see the relationship between here? So that means they are the inverse of each other's in this sense. Tangent of the theta is 1 over cotangent of theta, because tangent is y over x, cotangent, flip that fraction, is x over y. So that's the reason that we have this, or you could alternatively say that cotangent, it doesn't matter. One of them is the inverse, this is the relationship between these two functions. So, so in general, what are the identities? When we study trigonometric, we always deal with identities. So let's make clear that what do we mean by identities? Identities are equations that are true for all the input value in the domain, which means that, for example, if you say tangent is sine over cosine, this equation holds for all the input value in the domain of tangent. So no matter what is the angle, as long as you are within the domain, no matter what is the angle, you always have this equation hold between tangent and sine and cosine. So equations like this are called identity, and they are very fundamental in trigonometric studies. So now I'm going to show you the application of these identities. Here we have 1, 2, 3, 4 identities. Let's do a couple of examples to see how they are helpful. Okay, so we start doing examples. Let's do example 1. Example 1. It says evaluate tangent of, find tangent of, first it says what is the tangent of 45 degree. Okay, so that's simple. And then it says find the secant of, what is the angle? pi 5 pi over 6, 5 pi over 6. Okay, so let's first do tangent. Okay, tangent, what is tangent? The relationship, so I'm going to use this identity. I'm going to use this identity that tangent of theta is sine over cosine. Sine over cosine. I'm going to use this. So if you want to find tangent of 45 degree, you can divide the sine of 45 degree over with cosine of 45 degree. Okay, I know that for 45 degree, the sine is this value, the cosine is the same value. So it's gonna be 1. Okay, so the answer is 1. What is tangent of 45 degree? 1. So you see how did I use the identity in order to evaluate tangent of this function without any calculator? I use this identity, the first one. Tangent is sine over cosine. Okay, so now let's evaluate sine of secant of pi over 6. So what was secant? I need to refresh my mind. What was secant? So secant, I mean, not in terms of right triangle, in terms of identity. The relationship between secant and other trig function is that it is closely related to cosine. So secant is 1 over cosine. Let's try that because we know, let's try this identity that secant is 1 over cosine. Because we know how to calculate sine and cosine, so it would be more easier. Let's say if you want to find secant of 5 pi over 6, in terms of calculation, because we know cosine of pi over 6, then it would be easier to do the calculation. So it's just enough if we evaluate the cosine of pi over 6. And you can either use calculator, or I told you, I think that you need to, it's good idea if you know the basic fundamental, the values of sine and cosine for fundamental angles. So let's say the angle is 0, pi over 6, pi over 4, pi over 3, and pi over 2. It would be very good if you know that what are the sine and cosine. For example, for 0, sine is 0, cosine is 1. Pi over 2 is the reverse. And for pi over 6, do you remember for pi over 6, this is, let's say this is pi over 6. Sine is half, cosine is a square root of 3 over 2. And if you want to verify that, you can definitely do that. For example, let's say you don't have it on top of your head, then let's say I want to verify that's what is sine of, for example, sine of pi over 6. Pi over 6, yes, it's half. So and okay, so now I'm looking for cosine of 5 pi over 6. So that's gonna be in here. Look, 5 pi over 6. It's gonna be pi minus pi over 6. So it's gonna be here. 5 pi over 6 is this angle because it has pi over 6 less than pi, right? So so it's gonna be the same value. The cosine of pi over 6 is gonna be the same as cosine of pi over 6, which is a square root of 3 over 2. So this is gonna be a square root of, look, this is gonna be 1 over a square root of 3 over 2. They have same cosine value, but because 5 pi over 6 is in the second quadrant, it's negative. That's the only difference. So it's negative. Okay. So that's it. So secant So it's going to be, if you want to further simplify, this is going to be -2 over square root of 3. Okay. So the whole point was that here the idea is that you use these identities. So for example, you want to evaluate secant of a function. Instead, calculate the cosecant, for example, cosine of that function, and then just reverse it. Just reverse it, like flip it. Then it's going to be the value for secant. So the idea is just using these identities in the calculation. And here is the work in your textbook as well. Okay. Now, let's simplify this one. So sometimes we can, I mean, look, you can play with these trig functions, create combination of them, and then you can simplify them. For example, here we have secant over tangent. This is a function, right? We can create that. You can create any function that you want. In this example, this is example 2, we have secant divided by tangent, right? Secant divided by tangent. The question is simplify this. Let's see if we can simplify this further. So remember, we started with sine and cosine. So always, if you can reduce the function in terms of sine and cosine, that would be interesting. So what is secant? Secant is 1 over cosine. What is tangent in terms of sine and cosine? Tangent is sine divided by cosine. Okay, so I just use the identity to replace secant and tangent. Now let's simplify. So you can cross these. So it's going to be 1 over sine of theta. Okay, so that's one way to represent it. But also 1 over sine of theta is cosecant. What was the identity here? Look, cosecant is 1 over sine. So we can simply say that this is cosecant. You see that? So we prove that when you simplify this secant divided by tangent, secant divided by tangent is the same as cosecant. And the proof is right over there. Okay. So we substitute secant and tangent, we simplified, and then we use the identity to express it as cosecant. Now let's prove this identity. So this is given, and let's see why this holds. So on the left side, we have 1 plus cotangent over cosecant. So this is example 3. On the right side, we have 1 plus cotangent. What's the notation for the angle? Alpha. Cotangent of alpha over cosecant of alpha. Okay. Equal sine plus cosine. It says that it is equal sine plus cosine. Let's see if this is really hold. So, look, whenever you have a question like this, or equation like this, I mean, which side is makes sense to make it simplified. On the right side, I have sine plus cosine. Okay, sine plus cosine. How further can I simplify it? Not much. But on the left side, I have 1 plus cotangent. Okay, we know that we have identities for cotangent, so we can simplify it. Here is cotangent, so I can simplify cotangent. And cosecant also has an identity, so I can use this identity to replace them with sine and cosine function. So let's do it. Cotangent is cosine over sine, so it's gonna be 1 plus. So cotangent is cosine divided by sine. That's the from identity. Cosecant is 1 over sine. Recall, cosecant is 1 over sine. So cosecant is 1 over sine. Okay, so I started from left. I started from left, which means that from left side of the inequality, I started substituting, using identity to substitute cotangent and cosecant. Now let's simplify it. So on the top, we can take a common denominator. So it's going to be sine of alpha plus cosine of alpha. And this is the denominator. Now we can cross this. So we end up with sine plus cosine. So when you use the identities, substitute the values, and then you simplify it, you see that, yes, in fact, we reach the left side is the same as the right side, sine plus cosine. So we prove that the identity, this identity holds. And here also is the step-by-step description. How about this one? Let's look at this one, example 4. Example 4. Cosine square over 1 plus sine. Cosine square over 1 plus sine, 1 minus sine equals 1 minus sine. Let's see if this holds. The question give us this identity, and it says establish it, show that this exists. So I'm gonna start from left side, okay? So show that this exists, show that the identity holds. That's the question. So I'm going to start from the left side, cosine square over 1 plus sine. I can simplify that because there is identity that, recall the fundamental identity. Do you remember that we had sine square plus cosine square equal 1? Do you remember this identity? I'm going to use this identity here. So cosine square, maybe I should write this down. Maybe let me write it somewhere. Okay, so look, we know that there is a fundamental, we learned this before, that there is a fundamental identity, sine square plus cosine square is 1. So from here, I can solve it for cosine square. Cosine square is gonna be 1 minus sine square. Okay, so I'm gonna use this to substitute cosine square. It's going to be 1 minus sine square, okay? And denominator is 1 plus sine. Okay, so I just use this identity in order to simplify the numerator. But we can still simplify this because this can be factored. 1 minus sine square can be factored as 1 minus sine times 1 plus sine. And here I'm using for the numerator to factor it, I'm using this algebraic, do you remember x square minus y square is x minus y times x plus y? So here I am using this algebraic equation or formula in order to factor the numerator, because we have, it's like having 1 square minus sine square. So it's like having, yeah, it can be factored in this way. And then you can cross this by this, you see? So it's gonna be just 1 minus sine. So we reach the right side, you see that? So look at the approach. We started from left side. So we started from left side and we kept simplifying, and we end with the right side. So this means that the cosine square over 1 plus sine is 1 minus sine of theta. So the identity holds, you see? So here we use this identity. First, we use this identity to substitute cosine square. then we factor the numerator, and then we cancel, and then we establish the identity. There are also alternative formats of this fundamental Pythagorean identity. So this is the Pythagorean identity that I already used. Sine square cosine plus cosine square is 1. Another version, the version that has tangent, is 1 plus tangent square is sine square. And here is the proof. Maybe I just go over the proof. Look, 1 plus tangent square. So what is 1? 1 is cosine square plus sine square. And actually, this is secant square, right? Yeah. So look, we let's say we divide both sides of Pythagorean theorem by cosine. So that's it. So maybe I write the steps. Look. So the identity, the Pythagorean identity is that sine square plus cosine square is 1. Now, we can derive another version of this. Divide both sides by cosine, okay? Divide both sides by cosine square. So then sine square over cosine, so it's gonna be sine square over cosine square, right? Plus cosine square over cosine square, 1 over cosine square. So now let's substitute them. Sine divided by cosine gives me tangent. So this is tangent square. Here, this gives me 1. 1 over cosine is secant. It's secant. So it's going to be secant squared. That's it. So we derive the new identity that involves tangent and secant. And I show you the proof. So we started with the fundamental identity and we derive this identity. 1 plus tangent square is secant square. Similarly, you can also derive an identity for cotangent, an identity that relates cotangent square to cosecant square. Now, I'm gonna show you an application of this. Example 5. Let's see an application of this. Example 5. So we have tangent is 2 over 7. And theta is in the third quadrant. So theta is in the third. So theta is somewhere here. Okay, so this is theta. Theta is somewhere in the third quadrant. Okay. And find cosine. Find cosine. The question is, what is the cosine of theta? Okay, I don't know what is theta. If I knew that, so then we could have used a calculator. But here, we know the tangent of that angle. So that means we need to use the identities. We can use the identities in order to approach this. And an identity that relates. So here is the thing. We need an identity. So here is the approach. We need an identity that only involves tangent and cosine. Why? Because look, we know the value for tangent and we are looking for the value for cosecant. So for example, you may say why you're not using tangent, which is sine over cosine. The reason is that I know the value of tangent and I'm looking for cosine, but I don't have the sine. So this is not going to work because I don't know. I have two unknowns here. So I'm looking for I should look for an identity that only has tangent and cosine. Then I substitute the value of 2 over 7 for tangent, and then I can solve it for cosine. Which identity has that feature? So if you look at the identity, this one involves tangent and secant. Since secant is 1 over cosine, so if I so let me show you. Look at this identity, 1 plus tangent square, we just proved that, is secant square, right? That is just what we proved, that 1 plus tangent square is secant square. Now, the thing is that you can substitute this by, because secant is 1 over cosine, right? This is what we need to really use here in this question. Why? Because in this identity, the functions that are involved is only tangent and cosine. So I know the value for tangent, so I can say the tangent is 2 over 7. So we can substitute 2 over 7 for tangent, and then we can solve this equation for cosine. You see that? So that's it. The rest is algebra. So this is going to be 449. And then if you take a common denominator, so this is going to be 53 over 49, right? So flip it, flip the fraction. It's going to be 49 over 53. It's going to be cosine square, right? So cosine is going to be a square root of that. Take a square root. That's going to be cosine. But when you take a square root, it can be positive or negative. Remember, always when you take a square root, the answer could be positive or negative. But here, since the question says theta is in the third angle, so look at the cosine. So cosine is here. So cosine is a negative number. So we need to take the negative number. This is not acceptable. It's the negative number. So that's it. We calculate the cosine. So cosine of this angle is square root of 49 divided by 53. So you see, the idea was that to answer questions like this, we need identity. But which identity? So far we have learned so many identity. Which one? The one that, like this one, when you substitute the values, you end up with only one factor, and that gives you one unknown. So you can solve it to find here. Here also is the approach that, here is the approach that I explained, that use this, substitute, and then for cosine, cosine is gonna be a square root of 53. What did I say? Yes, it's a square root of, wait. Yes, cosine is a square root of 49. I didn't simplify it. Your textbook simplified the square root of 49 and said this is 7. So your textbook says that negative, by the way, it's negative. So the textbook says it is negative 7 over a square root of 53. Okay, because the square root of 49 is 7. So that's what you see here. Cosine is negative 7 over square root of 53. Okay, that's all for this. So as long as you know these three function, sine, cosine, tangent, cotangent, secant, and cosecant, and you know the trig identities, you should be able to do all sort of exercises. So I encourage you to look at the exercises of this section, and I think now you should be ready to start the homework assignment for this section. Thank you for watching this video. I'll see you in the next one.